Good evening, friends. Today, here we are going to discuss the algorithm behind the DB scan. So, what and how our DBs can do the clustering of the data points. So, our first step is we assign the minimum number of points and a value of epsilon or radius. Okay. So this is our point one. Like suppose I have decided that minimum point will be 3 and radius suppose I take 1 unit. Now let me tell you what is this. Like suppose I have my data set. Okay, this is my data set. Hmm. So what will happen? Radius and minimum number point. Here you can see a lot of data point here. In DB scan clustering, each data point is classified under three categories. One is the core point, one is the border point, and the last one is the noise. So, which data point is called a core point? Suppose I take a data point and I take a radius from it, that suppose which is 1 unit, that is epsilon, and then I make a circle around it. And if I found that the number of points within this circle is equal to or greater than the minimum number of points, then this data point is called the core point. Suppose I have taken here 3. So let's suppose here it comes 4 points. So this will be termed as a core point. Okay, now let me tell you about border point. What happens in border point? I take a point, again I take a radius epsilon, and I make a circle. Then suppose what happens in border point is that border point is a point in which the number of points are less than the minimum number of points, but it has at least one core point. Then that point is considered to be a border point. Okay. Now third is the noise. Suppose I have taken a data point, then again I take the radius, I draw the circle. So, what happens in noise is a data point is considered to be a noise if the number of points inside this circle is less than the number of points which are minimum, and no core point is also present in this particular radius circle. Then that data point is termed as noise. So, you must have understood that what are core point, border point, and nose point. So this is the reason why we first initialize our minimum point and the radius, so that we can classify our data points into these three categories. And this was nothing but our first and the second step. Step 1 is done. This was the step 2 which we just did. That is uh, identifying. That is to identify all the points as a core point, border point, and the noise point. Now what we will do is, now suppose we want to do the cluster, then how we do the clustering? Suppose I have some points like this and this. Okay, so what will happen? Suppose if I take these points and let these points are the core point, I have suppose that these are what, these are my core points. Okay, so what will happen? I will check whether this and this point and this point are density connected points or not. Then what are density connected points? Two points are called density connected points if the distance, if suppose any point come between them, like suppose let me take this two as an example. If any point comes between them, it should be a core point, and the condition is that the distance between the core points should be less than or equal to the epsilon, that is radius. Okay, now this was the core point, this was the core point, and also the radius between them was equal to or less than epsilon. So what I will do, I will just make a cluster of these. Now I will check for point 1 and point 3. So this is a core point. Okay, now in the distance also I checked, then this was less than that, then I make a cluster this. Now I again check the point 1 and point 4. This is also 4 point, this is also 4 point, and the distance between them is also less than equal to epsilon. So I again make a cluster. So now again check for point 1 till point 6 or 5. Now here if I will check, I will get to know that yes, they are core points, it is correct, but here the distance has become greater than the epsilon, so no, this will not come part in this cluster. So my cluster 1 is ready. Okay, this is how we prepare our first clusters. We go for each core points and we cluster them. Okay, now suppose what will happen after making cluster of all the core points. Our new aim will be to handle our border point. Suppose this was our border point, then what will happen, it will be the part of that cluster who which is at a minimum distance to it. So this was a core point and it is at a minimum distance from this. My border point is at a minimum distance from this, and suppose there was another core cluster, but the distance of this from these core points are more, so it will become a part of this cluster only. Okay, so you must have understood that how we make cluster for the core point and the border point. Now what will happen, we are remaining with the noise. Now we do not add noise in any cluster, we leave the noise as it is. So this is all that how we make clusters in the DBSCAN, and you must be clear with this. Now there is a reason came, let me tell you why do we use the DBSCAN. The reason why we use DBSCAN is the failure of our k-means. What happens is that if I work with a higher dimensional data, then in such cases my elbow curve comes like this, and in such cases finding the elbow point becomes difficult. So there is a failure of the k-means. That's why we use DBSCAN. Second is that it is sensitive to the outliers, which I have already told you in the k-means video also, that we know that in k-means centroids are positioned, and then by calculating distance from the centroid we make clusters. But if there will be an outlier, it will distort the position of the centroid and cause disturbance in the formation of the clusters. Third is the complex shapes. If our data are present in some spherical clustering or spherical type, then the k-means can easily just cluster them. But suppose our data is complex, like it is this and this, then it is hard for the k-means clustering to assign clusters to them. It will make some mistakes. So these were the three reasons that is why we use the DBSCAN. Thank you.